Hello, Enriched Geometry students. What's going on? We are continuing our unit on trigonometry, studying our favorite trigonometric functions, sine, cosine, and tangent. Now, in this worksheet, we are going to be doing exactly the same thing we did in the last worksheet, except different. Okay, the last worksheet, we measured things in degrees. Degrees are rotations. Degrees are rotations. If you do a 360, you get back to where you started. You rotated. But how far did you go? Like if you're an ice skater, how far did your ice skates travel while you were rotating? That is more of the idea of a radian. A radian is a length. Okay. So, let's see, where were we? Radians are lengths. Okay. Now we're going to leave off the unit. So they don't look like lengths. So they could be inches, centimeters, feet, whatever. If you were going to build a table and you were in Europe, you'd probably use centimeters. If you were going to build a table in the US, you'd probably use inches. But the mathematicians just leave it off. And then depending on what country you're in, you can just put the unit on and build a table in whatever unit you want. Okay, so here we go. The radius of the unit circle is 1. Okay, the radius of the unit circle is 1. It wouldn't have to be. It could be 2. So then our answer could be like 2/4, which would reduce to 1/2. So you might as well just start with a 1, then you've already got the half to start with, and you save the hassle of reducing. Okay, if the radius is 1, the length around the circle is called the circumference. That's the length around the circle. Circumference equals pi times the diameter. Well, if the radius is 1, the diameter is 2, leaving that 2 pi. So pi is about 3.14, somewhere around 3. So for example, if the radius is 1 foot, then the diameter is about 6 feet. But we'll just call it 2 pi instead of 6 feet, which looks weirder, but it's more technically, like more theoretically accurate. Okay, now where are we? All right, so we have to scoot this out of the way, make it a little smaller and scoot it up here. Okay, so the circumference is 2 pi. So let's start here, just like we did in degrees. We don't want to confuse ourselves. We'll start in the same spot. So that's 0. If you go all the way around the circle, that length is 2 pi. Okay. So then halfway around is 1 pi. Then half of that is 1/2 pi. So you count 1/2, 2 halves. This would be 3/2 pi. And then all the way around would be like 4/2 pi. Okay. So that is how radians are set up. Okay. So one kind of weird thing is this is 1 or 1 pi. So our pizza, our whole pizza, our one pizza is a weird shape. It looks like a half of a pizza, but we're going to call that a whole pizza. So if somebody gives you that one whole thing, which looks like half a pizza, you could eat half of that. Okay, so keep in mind that that's the whole. Okay. Now, draw the angle on a unit circle, then find a positive and negative angle coterminal. That means also stops. Also stops. This is just like the last worksheet, except now we're in radians, lengths, instead of degrees. But we leave off the units, so they don't really look like a length. Like 5 pi over 6, how long is that? I have no idea. We'd have to convert it to a decimal and then tack on like inches. So we're working with lengths that we don't know how long they are. It's a little goofy, but I didn't make this stuff up. I just teach it. Okay. So this is 0. This is 1 pi. Where in the world are sixths? Let's see here. Let's see. Well, 1 pi is 6/6. So then half a pi would be 3/6. So let's see here. 6, they'd be about like 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, somewhere in there. 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. So those are all of my sixths, just for reference in the future. Okay, so these are all of my sixths. So 5/6 is 1/6, 2/6, 3/6, 4/6, 5/6. That one right there. That is 5/6 pi. Now we have to find something else that stops there. So instead of just going to 5/6 and being done, what else would stop there in the positive direction? Well, could we go all the way around and that much further? Sure. All the way around is 2 pi or 12/6. So the other positive answer will be 12/6 pi plus 5/6 pi. It's kind of like 360. 12/6 is the same as 360. We just added 360 to it. But it looks weirder. It says 12/6 pi instead of 360. So 12 plus 5 is 17. That is the positive answer. Now the negative answer, I would just count. Negative 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6. Negative 7/6 pi. Okay, the next one. Negative 8/3. Interesting. Okay, this is 0. This would be negative 3/3, because that's 1. All the way around is negative 2 pi, or negative 6/3 pi. Okay. So where in the world is 8/3? So my thirds is about 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. So these dashes are my thirds. Notice that 1/3 is the same as 2/6. 1/3 and 2/6 are the same. So when you're counting in sixths, you're going to count the 2/6, which reduces to a third. Okay, now we've got to count negative 8 of them. Holy cow, that's a lot of thirds. So negative 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3. It's that one. So I went all the way around and a couple more thirds. So that's negative 8/3 pi. Now what else stops there? Well, let's just go in the negative direction. Negative 1/3, negative 2/3. So negative 2/3 also stops there. Negative 2/3 also stops there. And positive, we'll just count. See, when you got the thirds dashes, there's not a lot of math involved. It's just counting now. 1/3, 2/3, 3/3, 4/3. I just counted. I didn't do any crazy math. So it's 4/3 pi. Okay. Now these are also our favorite spots. We like the sixths, the thirds, and the fourths because they correspond to our favorite triangles from the last worksheet. Fourths. This is 0 or 2 pi. 1 pi is there, which is the same as 4/4. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Okay, so let's count negative 5/4. So count in the negative direction. Negative 1/4, negative 2/4, negative 3/4, negative 4/4, negative 5/4. It's right there. It's that one. Okay. Now, what else stops there? So negative 5/4 was there. Now what else stops there? 1/4, 2/4, 3/4. Just count in that direction. 3/4 pi. Now what else stops there in the negative direction? Count all the way around. 8/4. That's all the way around. And then 5 more fourths. 8 and 5 is 13/4, and that's negative. Okay, so pause the video there and try these practice problems, finding coterminal angles just like before. Okay, good luck with that, and I'll see you in a bit. Are you finished yet? Are you finished now? Are you finished? Come on. You're finished? Excellent. Okay, let's move on. Now, find the exact value without a calculator. How are we going to do that? We have to remember our favorite triangles from the last worksheet. We love those triangles. That was our 30, 60, 90 triangle. The side lengths were 1, 1/2, and the square root of 3/2. That was from the last worksheet. And we also love the 45, 45, 90 triangle. The side lengths are 1, square root of 2/2, and the square root of 2/2. And by the way, if you guys like Khan Academy videos, and which I do, I've watched a lot of them, Khan explains things very nicely. He very likely would use slightly different sides rather than 1, 1/2, and the square root of 3/2. He might label it differently, but you'll get exactly the same answer. And I've debated over the years which way to go with. My way makes more sense, but his way is slightly easier to work with the numbers. So I don't know. It's kind of a toss-up, but I went with my way instead of Khan's way. But like I said, it's kind of a toss-up. All right. Thirds. Thirds are these dashes. 1/3, 2/3, 3/3. 4/3, 5/3, 6/3. Those are my thirds. So negative pi/3, that'd be negative 1/3. That's negative 1/3. That's this one. Now you always draw your triangle toward the x-axis. Okay, so there's your triangle. The radius of the circle is always 1. Now put in your other side length. The shorter side is 1/2. The longer side is the square root of 3/2. Now, thirds, 1/3 of the way around to 180. 1/3 of the way around to 180. A third of 180 is 60. So the reference angle for thirds is 60 degrees, which, by the way, I should have found first. Sorry about that. I wasn't thinking clearly. So that's how I got the sides of 1, 1/2, and the square root of 3/2. I find my reference angle first. Now, with my handy-dandy picture, I could find any ratio that they were asking for. The sine ratio. So, ka, toa. The sine ratio is the opposite side, so divided by the hypotenuse. Okay, so clearly the opposite side is square root of 3/2, but wait, that's going down. That's negative the square root of 3/2. The hypotenuse is just 1. That doesn't do anything. Divided by 1, so you get negative square root of 3/2. Okay, the next one. Fourths. Those guys were in the middle. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. 8/4 is the same as 2 pi. Now 3/4, well, 1/4, 2/4, 3/4 would be that one. That would be 3/4. Now you connect your triangle toward the x-axis. Now you find your reference angle. So it's halfway between the 90 and the 180. Okay, does that make sense? So 2/4 pi is the same as 1/2 pi. That's the same place as 90 degrees. Over here is 1 pi, or 180 degrees. We're right in the middle between 90 and 180, which gives us a reference angle of 45. And then the hypotenuse is always 1. That's the radius of the unit circle. And the sides are the same. They're both the square root of 2/2 and the square root of 2/2. But wait, You're going back and up. You're going back and up to get to there. Now tangent, I don't have room to write it on top, so I'll write it down here. TOA, the tangent ratio at 3/4 pi, which is very useful for finding side lengths and angles of a triangle. The tangent ratio, that's the name of the opposite over the adjacent. So at 3/4 pi, what's the tangent ratio? I don't know, but I'm just about ready to figure it out. Okay, my opposite side is the square root of 2 over 2, and my adjacent side is negative square root of 2 over 2. So I get the square root of 2 over 2 over negative square root of 2 over 2. Anything over itself is 1, and a positive over a negative is a negative. So what's the tangent ratio at 3/4 pi? -1. How interesting is that? Okay. The last problem. Sixths, those were the little guys. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. 6/6 pi is the same as 1 pi. 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. So we have -1, 2, 3, 4, 5. That's that one. So now we make our triangle toward the x-axis. Okay. So we found it -5/6. That's that one. Right there. That's -5/6 pi. Okay. Now we're 1/6 away. So this is our reference angle. That's going to tell me what my side lengths are. So 1/6 of the way around to 180. A sixth of 180 is 30. So the reference angle is 30, which means the hypotenuse is 1, the opposite side is 1/2, and the adjacent side is the square root of 3 over 2. But you're going back and down. It's sloppy, but they're both negative. Okay, now the cosine ratio, ca, is adjacent over hypotenuse. Now the adjacent side is the touching side, and the hypotenuse is the side opposite the right angle. So it's negative square root of 3 over 2 over 1, but that doesn't do anything. So it's just negative square root of 3 over 2. And I hope I explained that fairly clearly. We'll talk to you guys soon.